So today I want to cover section 6.3, confidence intervals for populations proportions. So again, this confidence interval, we're talking about this population parameters. Remember how we had been working with the population parameter mean, and we were using a point estimate to estimate how confident we were that the population mean fell between a certain interval. So now we're going to approach this with the population proportion. So remember, the population proportion, we use the, let's see here, if we can get this. Hold on a second there. So as I was saying, we use the letter P for the population proportion. So we want to create a confidence interval, how confident we are that the population proportion falls within a certain interval. Again, the way we want to do this, though, is we want to use a point estimate. This point estimate we want to use is we're going to use this thing called p hat. P hat is going to be defined as the sample proportion. So to determine the sample proportion, X is going to be defined as the number of successes, and we're going to divide it by the sample size N. Now remember, along with successes is we have failures. So this P hat is going to be our successes, and this Q hat is going to be our failures. And remember, successes does not necessarily mean successes. It's just whatever they're considering, what they're looking for in the documentation. So let's look at an example here. We're trying to find a point estimate for the population proportion. So in a survey, there was 1,550 US adults, and 1,054 said they use social media website Facebook. Find a point estimate for the population proportion of US adults who use Facebook. And just by looking at the data, this seems fairly reasonable because I think most people do use Facebook. So this sample size sounds like it does represent the population. But notice how it is a sample. It does not represent the whole population. So this would be considered a sample. So we're going to determine p hat, which is going to be the sample proportion, if you will. And notice that we had 1,054 was those that said they used the social website, Facebook, and the amount surveyed was this 1,550. So notice how we usually don't leave it as a proportion. We actually change this into a decimal. So if we divide the 1,054, if we divide that by 1,550, that's going to give us then this 0.68. Like, so a lot of times we'll read this 0.68 as a percent. So 68% would be saying they do use Facebook as a social media website. And that sounds fairly reasonable. And again, a lot of this is based on, what age you are in the population as well. So let's look at another example here before I stop the video. In your homework, you may be given a confidence interval, and you may have to be finding the margin of error and the sample proportion. So we've already talked about confidence intervals from previous sections. So notice how here we could break this back out as an inequality. So 0.758 is less than P, which is going to be less than 0.784. So that's our confidence interval. So what they're saying is our population proportion, they're confident that it's between these two values. So between like 75.8% and 78.4%. So what they want us to do, though, is they want to determine the margin of error. No, so notice again, if we go back to our algebra instincts, if we draw this like on a number line, the 0.758 is our left bound, and the 0.784 is our right bound. So the margin of error is how far we move from the middle. So we have this middle value here, which we'll call our p hat, if you will. So our sample proportion. So to find the margin of error, notice how we could determine the full distance across here. If I want to find distance, remember that's a subtraction problem. So it looks like I wrote that down wrong down there. That's should be 0.758. So if we go for the margin of error, a lot of times we'll use capital E for the margin of error. That's going to equal, if I go 0.784, if we subtract 0.758, that'll give us the total distance. .026. Notice how we have to actually divide that by 2 because the margin of error is half of that distance. So this 0.026 is going to have to be divided by 2. So we'll get this 0.013. So 0.013 is going to be this distance here. So that's how far we move from the middle. So the middle is actually the sample proportion, how far we move. So if I want to find the middle, that's actually the midpoint. So p hat, the sample proportion, if I want to find the middle, that would be like the midpoint. So what you can do is go 0.758 plus 0.784. And if you divide that by 2, that'll find your middle. So if you go 0.758 and add 0.784, if you divide that by 2, that would give you 0.771. Notice also, you could have also simply added the margin of error to the 0.758. So if you had the 0.758, if you went from that endpoint, if you added the 0.013, that should also get you to the middle of that 0.771. So there could be a couple different ways to approach finding that sample proportion, the middle there. So I'll pause the video here and we'll look into the next section.